So hi everyone. So guys, am I audible? Okay, right. So in the last two constants we left up to primary key we discussed in the last class. Okay. So now we will go for the next one is okay, the foreign key constraint. So foreign key, or else we called as here references key also we can call. So basically foreign keys, okay, why we want to use this foreign key? Okay, what is the purpose of this foreign key we need to use? Okay, so by using a foreign key, we need to make relationships. So whenever you want to create some relationships in between tables, so compulsory the foreign key reference must be we should take. Okay, and the relationships. Okay, how we can go to create it, and what kind of the basic conditions are there to create your relationships, and after creating relationships, how you knows these tables are having the relations or not. Okay, and what kind of rules are there. Okay, and those rules how to check. Okay, these all kind of information we can check in our foreign key constant. Okay, now so the first thing is foreign key is used guys here to create. So whenever you want to create here to create relationships, to create a relationship, okay, so between tables, okay, right. So now this relationships, okay, whenever we need to make it here, there are some rules we need to follow guys here. That's called as basic rules are there. So it's not like that I can create my relationships in any manner. Okay, so we need to follow some rules here. And what kind of rules we need to follow here? Let me come out and check. In this, first rule is what now? When you're making relationships in between tables, okay? So first of all, we should take a common column name. But your common column name is mandatory. Okay, if anybody asks you, so it's not mandatory, it is a optional. For our convenience purpose, our easy to identify purpose, okay, we are going to be taking some common column name. But common column name is not a mandatory for us. Okay, but just our easiness and our easily understandable and easy to identify the which is my referenced column. So that kind of identification purpose, generally in real time, the people will taking what now? Common column. Okay, so here the first point is what now? Common column name. But this is what I'm showing here, optional. Okay, so common column name may be optional, but data types must be matched. But data types must be matched here. Okay, so this is one thing should be remembered. So name is maybe different, but those columns data types must be matched. That is one thing. And the second one we called as here. Okay, what is the next one we have? When we created the relationships in between table, so compulsory one table should have a primary key constraint. Okay, and another table, that means one more table we should have, or else other table, okay, should have here foreign key constraint. So these are compulsory. So between which tables you need to create your relationships. So in these two tables, okay, must and should be have one table primary key and one table foreign key. So that is the second one we need to check it out. Okay. Then after your third point is what now? Every primary key table. So that means when you applied primary key on a particular table, so the table how it will be treated by your database server means the table will treated by your database server, okay, as what now? Parent table. It was treated as a parent table. So that means what I'm saying here, the primary key table, okay, the primary key table is called as a parent, okay, and foreign key table and foreign key table, okay, so is called as your child. So that means whatever the relations I'm going to create it here, the which type of relation I'm going to create it in between tables means yeah, two types of that means parent and a child relations we are going to be created. Okay, now which kind of relations means parent and child relations. Okay, now so now here the next one is, suppose are you designing? Okay, are you designing some column? Okay, for example, one of my column is a serial number. Serial number is a primary key column, guys. Okay. And another table, okay, serial number. So here I will take a foreign key. So these are the two tables, okay, common column. And one table common column is having what now? Primary key. One table common column is having foreign key. So now how the primary key means you already know. So primary key will not allow the duplicates and null values. So that means I'm giving here 10, okay, 20, okay, and 30. Suppose these are the values in the primary key. So primary key is having the whatever the values here are there, same values are accepted and allowed by foreign key. Understand now? Because of reason, the reason is what now? Primary key we called as what now? Parent. And foreign key is what now? Child. So a child table data must be in the parent table. Okay, na? It's a simple, easily understand. So nowadays, you know, parents and children's or parents and child informations. Okay, now. So a parent can have any number of children's. Yes or no? So a parent can have any number of children's. Okay. So now here also, whenever the child table will accepting the data should be there in a parent table. Okay, now data should be there in the parent table. So parent table here, what it was here, 10, 20, 30. So that means how many parents we have here? Three parents are there. Understand now? So now if 10, 20, 30, the same value here accept 10 is allowed. Because 10, why child table is allowed here? Why 10 is allowed child table means a parent was there. So when parent is there, the parent corresponding children's we can accept. So it is allowed. Suppose second, if I'm sending 10, come on, it allowed or not allowed? What is your guessing here? Yes, it's allowed. So why, sir, it is allowed 10? A parent can have any number of children's. The first should be remember. A parent can have any number of children. So 10 is allowed. Next, if I enter 20, allowed. So one more 20, allowed. 30, allowed. 30, allowed. 30, allowed. So that means here, so like this foreign key will accepting here. Okay, so the values. And for example, if user sending here 40, so whenever user try to inserting 40 number or 40 value, then what it was saying that 40 is what, or else the 40th parent is there in my child, is there in my parent table? No. So 40th parent is not there. Is not there means the 40th parent is not there means it was showing not allowed. Okay, now, so because of reason here, how many parents we have here? Three parents. 10 is a one parent, 20 is a one parent, 30 is a one parent. Okay, now, so 10th parent is having how many children's? 10th parent is having how many children's? Come on, guys. Ah, yeah, 10th parent is there. So 10th parent is there. So 10th parent is having how many children here? Two. And this 10th parent is having two children. In the same to same, next 20th parent is there. 20th parent is having, okay, two children. And next we have here 30th parent is there. So 30th parent is having how many children? Three children. Okay. So these are the belongs to that parents. Okay, but 40 child, the 40 child whenever inserted into child table. So this parent was there here. No, so 40th parent is not available in my parent table. 40th child is not, okay, 40th child parent is not available in parent table. So that means this is unreferenced value. This is a unreferenced value we called. And these unreferenced values are not allowed. Understand now? So it was going to showing error. But here, very important point. Suppose if I'm going to insert 40 is not allowed, okay. But what about null, sir? So, sir, can I insert a null? Ah, so what is your guessing, guys? Null is allowed or not allowed? Okay, so here some people saying allowed, some people saying not allowed. Null is allowed, guys. Null is allowed. So null is allowed. Why, sir? Null is allowed means here in this relationships, the null how it will be treated by your Oracle server means it will be treated like a orphan value. Okay, otherwise orphan child. So null why it is allowed, sir, means that your server will treat in this relationship, it is a orphan child. Okay. So orphan child means what now? Orphan means what? Come on, guys. Orphan means parents are there or parents are not there. Yes, parents are there. So parents are there, but who is that parent? We don't know. Okay, now so without parent, there is no child. Yes or no? Without parents, there is no child. So that means parents are there. Orphan child parents are there. Who is that? That we don't know. So that's why null is allowed. Why it is null is allowed means these parents are there, but who is that? I don't know. So maybe in the future, this orphan child parent may be 10. Maybe there is a chances. Maybe 10 is a this orphan child parent. Maybe in the future, 20 may be orphan child parent. Maybe in the future, 30 is a parent of this child. So in future, out of this, any one should be parent of null. So that's why it is accepted. So that is one reason you can say. Second, now null is nothing but what we said empty. Null is nothing but what we said empty. So the second reason is what now? Null is not considering any value that already we null is not consider any value. It's just a empty cell. So of course, the empty cells are there is no comparison. Yes or no? If it is a value, then comparison. So empty cells are no value. No value means nothing. So nothing means it will accept it. Space empty blocks are allowed. So that is one reason. So one reason is what now? Null if it orphan value, then orphan means what parents are there, but who is that exactly parent that we don't know. So that means in future, this orphan place, okay, we can find out their parents. We have second one is what I said. Null will be treated generally in database, what I said, empty. So empty blocks can allowed, nothing problem. So empty block means there is no value into that. So that's why comparison is nothing. So in future, in that empty cell or in that empty block, I can put some value. Understand now? I can put some value. So that is how it is. For example, suppose are you updating now? Update child table set serial number is equals to, suppose I'm giving, okay, 40 I'm giving, where serial number is a null if I'm giving. So that means what I am doing here in my child table, serial number column, null, okay, the ARPAN child value, I am updating with the 40. Is it possible to update? No. Why is it update? Why, sir, we can't update? Yes, because of reason. This 40, okay, because of reason, this 40 is not there in the parent table. Okay, can you check the 40 was there in the parent table? No. So there is no, okay, in your parent. So that's why what it was saying that it is an unreferenced value. So unreferenced values are not allowed. So that means your updation will not happen. Okay, so we can't. But tell me guys here, suppose if I want to give it here, for example, if I'm giving 10, can I update now? Yes, we can. So yes, we can. So yes, we can means what? Because 10 is available in the parent. So that's why I can accept this 10 into this place. Now it is 10. Now tell me this ARPAN child parent, who is that? Who is the parent of this ARPAN? And so that means in the future, this orphan child, if you found who is the parent of this orphan child, so then in future I can find out and modify. So that's why null is allowed. Suppose if I'm giving here, so next I'm giving here 20. 20 is allowed. Yes, 20 is also allowed. So 20 is allowed means now who is the parent of this orphan? 20 is the parent orphan. Okay, same as suppose in the future if I change 30, can I? Yes, that is also allowed. So that means in this, who is the parent of this ARPAN? That is, so that is the one reason. So ARPAN means what now? We have a parents, but we don't know exactly. But maybe in the future, 10, 20, 30, in these three parents, any one parent will be this child. Okay, na? So any one parent is a child of this null. Okay, now. So that is the cases it will be allowed. So that's why null is allowed here. Okay, now null is allowed. So that means what you say, it complete. Finally, you can conclude here. Child table is allowed or is accepting the values. Those values must be in the primary key. Yes or no? Those values must be in the that is a point here. Okay, so that means so foreign key column is allowed. Okay, column is allowed values which should be or which will be in primary key column only. Okay, in primary key, which will primary key column. Okay, na? So whatever the values are there in primary key column, so those values only acting by foreign key. Okay, na? That point should be removed. And the next one is what now guys here. Okay, the next one. By seeing of this information, carefully observed, by seeing of this information, by seeing of this information, can I say like this? Can I say this? Foreign key, okay, foreign key column is allowed duplicate and can I say now? By seeing of this example, so finally conclude like this, your foreign key is allowed duplicates and nulls. Can I conclude or not? Yes, I can conclude. Understand now? So these are the few things, guys, here whenever you want to use a or else a references key. If you basic these 5 points should be remembered. Okay. So when you maintain these five, okay, the rules, so when you maintain, and the relations will be established in between. Okay. Now let me see. I will show you the examples how to making relationships, and after that, what it was happened, that all we will check it out. So come back to your SQL Plus editor. First, I want to check it out how many tables we have in the database now. So these are some tables we have here. Okay. Now, so now I'm going to design here some tables. Okay, fine. So careful observe. Create table. The table name is DEPT1. Okay, and here I'm taking department number. On the department number, I'm taking and next department name. Okay, back up to of some sites. So in this, department number is a primary key column. Okay, now right. Now I design this table and insert into DEPT1 and sending some values, guys, here. Department, yeah, suppose sales department, 20. So production department. So I just made it commit to permanently save my data. Okay. This is my parent table. Okay. How I can say this is parent table? Because of reason, primary key was there here. Okay. So whenever it was having primary key, okay, then automatically we can say it is a table. Okay. That is our identification. And the next one, I'm creating child table. Careful observe. So EMP1, as usual, employee ID. An employee ID, you can apply unique and normals to making your, okay, making unique identities purpose. And the employee name, I have to take varchar2 of some size. And here reference column, I have to take. So in my second table, the reference column is what now, guys, here? Uh, Department number. So which column is the primary key column? That primary key column should take as a reference. Understand now? So now that's why I'm taking department number, same data type. On this reference column, I'm going to apply here, okay, a references keyword I'm using. Okay, na? References value. Yeah, references means what I said, it's called a foreign key. So foreign key, we also call that references key also we call. Okay, now? Right. So that's why here I'm using references. And now careful observe. This department number column, are you taking references from? Which table are you taking this column reference, guys? Come on. This column, are you taking from? DPT number reference column, are you taking from which table? Yes, DEPT table. That's why this column taking, okay, the references from DEPT1 table. Understand now? So whatever the column I'm taking here in my child table, so child table referential column are you taking from which parent table? So my parent table is what now? DEPT1 of in this parent, which is my column here in this parent table, which column I'm taking reference? DEPT number. So this is what the meaning of that. So DEPT number, whatever I'm taking in my child table, this column I'm taking references from so and so parent table. In the parent table, what is my reference column? DEPT number. Okay. Then after making this, okay, after making this to create. So my table, child table successfully created. So now what it was happened, carefully observe. This is my parent table and having some information in the parent table, 10, 20. Okay, that means two parents are there. Sales parents, production parent was there. So now I'm going to insert some data into my child table, EMP1, and sending values of employee ID number, employee name, and department number reference value 10 I'm giving. So why not or not? The 10 is allowed, guys, here? Definitely, it is allowed. In the second case, suppose I'm giving 2 comma Jones, I'm giving 10. Can I allow this? Yes, definitely, it is also allowed. Now I'm using 3 comma ln, okay, 20. Can I allow this? Yes, definitely. Now if I send here 4 comma Scott giving 40, is it allowed? No, not allowed. Why? Because this 40th parent is not there. It's very clearly telling us, see, my integrity constraint is violated. And what it was saying to me, parent key is not found. So why, sir, the 40 is not allowed means that the 40th parent is not found in parent table. So it was very clear output. That means clear error message. Okay, 40 is not found in parent T column. So that's why it is not allowed. Okay. But what we said, 40 is not allowed, but can I use a null here? So definitely we can use a null. Why? Because null is a empty, and also what we said, null is a ARP1. So it is allowed. So finally, come back here, guys, observe carefully. This is my parent table. Okay. And this is my child table. So the parent and child tables informations we have. Now what I'm saying here, whatever here empty was there or orphan is there here, this orphan, if I want to change in the future, I can. So update EMP1 set, DEPT number is equals to 11 or 12, where DEPT number is equals to what I'm saying here, DEPT number is null. Now tell me, guys, can we allow this? Twelve is allowed. 12 is allowed. The 12th parent is available in your parent table. No. So not there in the parent table. So that means it is not allowed. Simple. See, 12 is not allowed because parent key is not found. Okay, now right. But same case, when I use here in place of this, if I send 10, can I? Yes, of course. It was allowed. So after allowing this, can you go and check it out your parent table and the child table? You can see now in place of null, okay, we taken 10. Okay, now. So now finally these two tables you can go to check it out and tell me guys. In sales department, how many employees are working? If I'm asking to you, how many employees are working in sales department? Yes. In sales department, total number of employees, how many? One, two, three. Three people are working in sales department. So in production department, how many employees are working? Only one. Okay, now that we can date. So now this is making of relationship. So relationship advantage understand now? Is it clear? Okay, right, guys. So this is so finally the parent and child relationships. Okay, if you want to create here, so foreign key compulsory and your child table when you created, what it was happen, your child table referenced column, whatever we taken from the parent table, in the parent table, whatever the values we have, the same values are accepting by child also. So that means here what internally it is going to be happen means it is data verification is going to be happen. Okay. So before you want to insert some data into child table, first your Oracle server will checking that this data is available in the parent table or not. If it is available, then the data is a valid. If it valid, then allowed. If data is not valid, it is not allowed. So this kind of restriction, we already said to you, constraints are used for restricted, unwanted data. That is the use of constraint integrity rules. Okay, so first unique constraint, what it is restricted? Duplicates. Not null restricted, nulls. Check constant restricted your values with some condition. If true, allowed. Not true, not allowed. Restricted duplicates and nulls. Then foreign key restricted what now? Unreferenced values. Unreferenced values means what now? Values which should not be there or which will not there in the parent table. So if any constant you can observe, internally one mechanism is happening, common mechanism. What is the common mechanism there? Data verification. So data verification is going to be happen in every constant rule. Okay, now. So this is what. But sir, you have a doubt. Yeah, okay, sir. We are okay that verification is done. But after making the relationships in between the tables, okay, there are two rules are coming to picture. There are two rules are come to you. What kind of rules? Let me come out and see. First, this example I'm giving to you for your practicing purpose. Okay, right. This is what we are making relations. But once you are making relationships, yeah, two conditions are we need to check. Okay, so what is that? Uh, so when we created a relationship, a relationship between tables, there are two rules are coming to picture. Okay, what are the rules? First rule one is called as a insertion rule we called. So insertion rule, what it was tell us, what it was telling us means insertion rule, what it was telling, we cannot insert values into foreign key column, into foreign key column. Those values, those values, those values are not found in primary key column of a parent table. Okay, na? This is first thing. So this is the first rule will come to us. This is the first rule we need to check whether my relationships are right or wrong. Okay, na? So we can set values into foreign key column. Those values are not found in a primary key column of parent table. Okay. So now that was already happened. That already we discussed here. So now we try to insert 40, but 40 is not allowed. It was showing error. Parent key is not found. Parent key is not found. So this error is coming to you. This error is coming to you. So successfully that message we checked out. The rule, yes. So what it was saying, parent key not found. That's fine. Second rule is what? Rule number two. Rule number two is called as a deletion rule, we call it. So deletion rule, what it was tell us, deletion rule, what it was tell us means that, so deletion rule is telling us, okay, we can't delete, careful observe this rule, don't confuse, we can't delete a row from parent table. We can't delete a row from parent table. The parent row is having child rows in a child table. Child, the parent is having child rows in a child table without addressing to child. You cannot delete. Okay. The first rule is we verified, okay, parent is not found, so we cannot insert. But second rule is what it was telling us, we cannot delete a row from the parent table. That parent row is having child rows in child table without to child. So with it just means without information to the child, user cannot delete a parent rows. Okay, now, for example, let me see practically what it was happening. So finally, come to my table. These are the parent and child table. Finally, you have it. Okay, now, fine. So now what I'm doing here, I'm trying to delete the parent table data. Delete from parent table, the EPT one. So where DEPT number is equals to 10. So your user directly, he was trying to delete a data or a raw data from the parent table. So now what it was happening, you can see it's not possible. Your Oracle server will not give permissions to you to delete a row from the parent table. And what it was saying, this parent is having child records. So got it my point now? So which parent are you deleted here? Which parent are you deleted? Nth parent I'm deleting. Unfortunately, nth parent, whatever we deleted, this parent is having children's now. This parent is having children's now. Yes or no, guys? This parent is having children's. So here it was what it was saying that this nth parent is a founder child records. Okay, this parent is found child records. Okay, so that's why you cannot delete it directly. Okay, na? We cannot delete it directly. So this is our second rule is telling us. This is our second rule is telling us. So second rule, what it was telling us? Yes. Yes. Child record is found. So these are the two rules are coming to picture. So here I want to say it is not allowed. Got it now? So now my question, carefully observe my question. So what is rule one? What is rule two? We understand. Along with practicals, we check it out. In these two rules, suppose if I'm asking to you, or if you go to any interview panel, the interview person is asking to you, if as a user, as a programmer, we are as a user, as a programmer, if I want to change, if I want to break a rule out of these two, okay, if I want to break a rule out of these two, then tell me which rule can be it, guys. Which rule is possible to break it? First one or second one? So think carefully, tell me. Don't hurry, worry. Think first. Which rule can be possible to break? Come on, guys. First rule, second rule. Carefully tell me. And read first rule, read, second rule also read. Definitions I was given, read first and take it out. Which one? Yes. Here, which rule will be change means I have a chance to delete, break up here. Second rule I can break. Understand? Second rule only is possible to break. Because first rule, what it was saying to us, first rule saying to us, if there is a no parent, there is a no child. There is a no parent, there is a no child. So now tell me, is it possible to change my first rule? Come on, guys. First rule, what it was saying indirectly or directly, if there is a no parent, then there is a no children's. Uh, if you have any chances to change that rule, yes, there is a no chance. Okay. And even though God also can't change this rule here, yes or no, even though God also can't change this rule. Without parents, no children's. Okay. Right. So this rule we cannot. But what second rule is saying that we cannot delete a row from the parent table. That parent row is having child or children's, okay, is having children's in child table. What it was saying is without addressing to child. Without addressing to child. Understand now? So without addressing means what, guys, here? Without information, for example, without informing to child table, you cannot delete a parent data. There is a meaning. So here, without addressing said, without addressing. Okay, without addressing, we cannot delete. Suppose if you go quite opposite, with addressing, we can delete now. Yes or no? In the simple, without addressing to child table, we can delete a parent row data. It means what it was telling to me indirectly, if you address to the child, then we can delete. Okay. Yes. So that is the meaning. So that means we have a chance to change our second rule. Okay. But now the question will come to you. How to addressing, how to addressing to child table. This is our question. How to addressing to child table. Okay, na? So if you want to address to child table, there are two rules are there, guys. Those rules are called as a cascade rules we call. Some cascade rules are there. In this cascade rule, first one we called as a on delete cascade. Second one we called as a okay on delete set null. Okay, na? So first one we called as what now? On delete cascade, and second one on delete set null. Okay, so these are the two cascade rules. Mr. E.F. Gordon, the scientist of your relational database model. Okay, so he was given two rules are given us. So these two rules you can use and to delete your parent row data. Understand now? But what's okay? First rule, let you come out and see. On delete cascade rule means what? Okay. It was what it was saying that once we delete a parent row, then automatically child row also deleted. Understand now what it was saying? Once we delete a row from parent table, a row from parent table, then the corresponding, then the corresponding then the corresponding childs are also deleted from child table automatically. This is what it was saying. So once you deleted parent, automatically child also deleted. Understand now? Now example on this you can come out. So already the previous same example I'm taking now. Okay, no, but I just changing my table names. That's it. Remaining all are same. But table name I'm changing here, department number 2. This is okay, department number 2. Everything is same. And inserting data into department number 2, same to same. And here careful observe, child level careful observe, EMP2, EID into unique not null, E name varchar, and the reference column, department number, integer references of, and now tell me, I'm taking references from which table? Come on, this time I'm taking references from which table? Department number 2 table. Department number 2 of department number of, here I want to apply on delete cascade. Understand now? So on delete cascade, where you want to apply? On a reference, that means on foreign key column. Okay, on delete cascade, on delete set null, these cascade rules are applying on foreign key column only. Other than foreign key column, you can't apply any other columns. Okay, right. It was applied. Same as here also, EMP2, EMP2, EMP2. Got it? Huh? This is the simple, okay. So on cascade, I was applied. So let me see same as to is, I'll just go to copy this and execute it here. So table successfully designed, and I'm inserting some records into this. Okay. So in the same pattern, one more record I'm inserting into this. Okay. 2 records are inserted and making commit here permanently saved. Then after child table creations, so I'm taking child table creation. So to take it out, child table EMP2 and department 2 references. Then after that, as usual, you want to insert some records into this child table. How many children you want it. So that many children you can insert. Okay, it will be accepted now. And one more thing is, okay, right. And now you can see. So here also, I just make it commit. So finally, there are 2 tables I got it. Sorry. Okay. What is the table name? Select the start of EPT number 2. And second child table EMP2. Okay, fine. So now, okay, you have to go to delete operation. Delete from DPT number 2, where department number is equals to 10. So now I'm trying to delete a row from the parent table. Then what happened? You can see one row is deleted. After deleted, you can come back and see your DPT number 2 successfully deleted, but the corresponding child records also deleted. Come on, guys. Come on, guys. Okay, right. So this is what now on delete cascade rule is telling us. So that means finally it is allowed, and along with my parent table. So in the testing part, so now it is allowed. Okay, now this is. And the next scenario, that means the next rule is there. On delete set null. So this rule, what it was tell us, carefully observe. On delete set null, okay, here what happened? Once we delete a row from the parent table, okay, then the corresponding child rows, child rows means a foreign key column value. Foreign key column. Child row means foreign key column. Rows are convert into converting into nulls. Okay, converting into nulls automatically. So this is what we called as, guys, here on delete set null we called. Okay, now. So once we delete a row from the parent table, then the corresponding child rows means what now? Foreign key column values. Child rows means what now? Foreign key column values. Okay, child rows are converting into nulls automatically. Okay, right. And it's the same as come back here. The same example here I'm taking, but the table names I'm changing now. This time my table name is 3, and here 3, and here also 3. And this time my child table number 3, taking references from 3, and on delete set null. On delete set null. Okay. Then after, so you have to insert your data 3. Next 3. Okay, now number 3. I tried. So same thing, you just come back and see. Okay, so parent table successfully done. Then come back to your data I'm inserting into parent tables. So first row, and same as the second row. And after we make it commit, I will take my child table with the set null statement. Okay, so now it is also happened. And now to insert some records into this table. Okay, fine. And now it is also, I just commit now. So finally come back to your tables. Okay, EMP number 3. And now as usual, now we can go to delete a row from the parent table. So delete from I'm sending here. So where EPT number equals to 10. And deleted, after deleted, you can come out and see parent. So now 10th parent details are deleted. Come on, deleted. Yes. And same as if you want to see in the child table. So carefully observe in the child table what it was happened. Parent row data deleted. That's fine. Okay. But the child records, whatever it was there, the child records are not deleted. be there here, but only that a foreign key column values are just converting into nulls. So empties are it was making now. Understand now? So this is what we called as guys here on delete set null statement. Okay, fine. So these are what now? Okay, on delete set null. Okay, on deleted cascade. So we have these are the two cascade rules are there. Whenever you deleting okay data from parent table and that parent data or parent row data is having children's in child table, not addressing, we cannot delete. Okay, na? That's why what we want to do before you want to delete a row from the parent table must be addressed to child table. So once you address to child table, then only parent data can be possible to delete or can be deleted. Okay, na? Otherwise we cannot. So that point should be remembered. Okay, so these are the two rules we got it. Okay, now fine. So now these are the foreign key constant working nature. Now the next requirement is what now? Okay. So as of now, we applied constant table. So unique constant, check constant, primary key, foreign key, as of now we apply. Okay. Now, so sir, whatever the constants I applied on particular column, those constants are see it. That means I want to view. Okay, now so on which table, on which column, which type of constants applied, that constants details I want to view, sir. So how to see it? My point understand now? Come on, guys. My point understand all of you? How to view constants details which we applied on the table. Yes. Okay, now suppose there are so many constants we applied here. For example, I'm taking one example also to get some idea. Suppose are you creating one table? Create a table. One of my table test 100. In this 100, I will take some serial number integer. On the serial number, I applied primary key. Next, some S name. On the S name, I applied, for example, okay, so unique constant. I'm applied here unique constant and not null. Next, I have your SP. So SP is a number of some size. I applied not null. Okay, now then I applied check constant. So check off student fee is greater than 2,500. So finally I closed. Suppose, just imagine. Now here serial number column I was applied primary. Yes name column we applied unique and not null. SP column applied check constant. So I'm creating this table. So after applied my particular table and whatever the constants you applied here, those informations I want to see. Okay, na? On which table, on which particular table, on which particular column, which type of constant are you applied? That constants details, what we applied on a table, those constants details I want to see. Anybody has doubt? Sir, how I can see constants on a particular table in Oracle database? Anybody getting this idea? Yes. So how I want to see my constraint details. Okay. Then there is a one topic here there, and not only constraint details in Oracle database. Very important Oracle database. If internal information about your database objects, okay, or tables, whatever it is. So there is a one topic we have here. Some tables are there. Those tables are called as a data dictionaries. We called data dictionaries. We called data dictionaries, even though we called as a read-only tables. We called read-only tables. We call. So, what is data dictionaries and read-only tables? For example, just I said, suppose this is your database now. This is your database now. So, in my database, suppose this is my DB 11 AM database. So, in my database, I'm creating some table. I'm creating some tables. Suppose I'm creating one table now. This is one table. This table is called as a EMP table. Okay, now? So now my question is, on this EMP table, what kind of the additional facilities we applied? What kind of the additional facilities we applied? So that every additional facilities, what we applied on a table, those informations I have to see it. Understand that those informations I want to, for example, on this EMP table, user is applied constraints. User is applied constraints. Then these constraints information where it will be saved by Oracle. Understand? Na? So are you creating one table here? On the table, you applied some constraints. Okay, na? But whatever we applied constraints on this table, those constraints informations where it will be saved, that constant information, how user will know, sir, how user can see. Okay, na? So that kind of. So where it is, sir. Okay, instance what we applied on a table. So that constants, all details are saved into one data dictionary. One data dictionary, DD1, for example. In the DD1 data dictionary one, in this one, constants informations are same. Same as suppose on this table, I am created what now views. So what is view? All I will explain to you in the future. Don't worry. Okay, now right. So whatever the views I created based on EMP table, these views will be saved into or stored into another data dictionary. Okay, another data dictionary. Like on this table, suppose I'm creating synonyms. What is synonym also future will discuss. These all synonyms informations are saved or storing under one more data dictionary that is called a data dictionary number 3. So like this, okay, suppose on this table, like this on this table, you applied a sequences details. Like this on this table, we applied indexes, index details. On this table, we applied clustered information. On this table, you applied, okay, what we can say procedures information, triggers information. So on a particular table, what kind of new facilities or mechanisms you applied, that every mechanism related informations you need to see, you need to view. Understand? Then there we will go for where now? Data dictionaries. So like this, there are so many data dictionaries are having here. Understand that there are so many data dictionaries are having here. Every data dictionary will say one specific and particular information about tables. Understand na? Ah. So this is data dictionaries usage. And this is important for us because if any information you want to see, compulsory you should go data dictionaries only. Okay, na? Right. So that is what I'm saying here. Data, it is a system. It is a system defined table. Okay, na? It is a system defined table. And these tables are automatically preparing by system at the time of Oracle software. So whenever you are installing your Oracle software, along with installation process, internally some tables are created by system. And these tables are called as a system tables or predefined tables we call. So that data dictionary is also one of the predefined table or system defined table. Okay, right. And these tables, if it is a table means compulsory, it will be store some information. Na? Yes or no, guys? If it is a table means compulsory storing some information or not? Come on. Yes, compulsory it will be store some information. So what it will be store means, so these data dictionaries, are are storing are storing the information about storing the information about the tables, comma, views or tables, comma, constants, comma, views, comma, synonyms, comma, indexes, comma, procedures, comma, functions, comma, triggers, okay, comma, triggers, etc. So different the informations, whatever applied on the table. So there are these all we are learning in our classes. Don't hurry. So now we are starting. Now we are working constant. Next we will go for we use the synonyms one by one topic wise. We will discuss this all. So that's why don't hurry. Okay, na? Right. So this kind of any information which will be saving under data dictionary. Okay, na? So every data. So every data dictionary will saving that particular information. Okay, now for example, so tables informations are in one data dictionary, constants are in one data dictionary, views are in one data dictionary, synonyms are one data dictionary, indexes like procedures, like functions, like triggers, etc., etc. Okay, na? Right. This is what. But these all, okay, data dictionaries, if I want to view, how I can see. Okay, suppose if you want to view, if you want to view all data dictionaries, okay, in Oracle database, then we follow the following syntax. Then we follow the following syntax is, what is the syntax here? Observe. Select star from. Okay, na? What is your dict? So your dict is nothing but, okay, dict is nothing but dictionary. This is called a main dictionary. Okay, dict is nothing but main dictionary. In this, all sub dictionaries are will save. Okay, dictionaries are saved. Now we can see how many data dictionaries are there. Let me come out and execute now. I'm writing select star from dict. Okay, let me see how many are there. Okay, so almost 1,000 plus dictionaries. Understand now? Almost we have how many dictionaries? 1,000 plus dictionaries are there. These are all our dictionaries. All our dictionaries. See, user underscore jobs, user underscore indexes, jobs, dictionary. This is a main dictionary. Yes or no? Main dictionary. Like this, so many are there. These are all are called as a user underscore tab underscore columns, tables, synonyms. Okay, clusters, catalogs. Yes or no? So these are the so many data dictionaries. User sequences, recycle bin, outlines, and okay, object usage, objects. So many are there. So many are there. So these are all are called as a data dictionary called, and every data dictionary storing some information. Okay, storing some information. My point understand here, having the dictionaries. These are all. Got it my point now? Right. So this is what. So like you can see, almost 1,000 plus data dictionaries are having in my Oracle database. And these are all are called as a system defined tables or predefined tables we call. So whenever you want installing your Oracle software, automatically, internally, these tables are going to create. Okay, na? Right. So like this, we can go to see it. But okay, fine. So now I want to view what I want to view. I want to view my constants informations. Okay, so on a table, how many constants I was applied, which type of constant I was applied, on which column I was applied. Okay, these kind of internal informations, if you want to see about constants, then we have a one data dictionary. So the data dictionary, what it is and how we can see that I will show you tomorrow. Okay, so this is today in the data dictionary definition I was given. Tomorrow I will show you, you can see the constants which we applied on particular table. Okay, right, guys. And notes now upload here. I'm going to upload this notes to you in your Google Class. Just a moment. Okay, so that I was uploaded and do once practice your side also. Okay, right. And yes, if anybody have a doubt in this session, so stay there and no doubts, people log out. Okay, right, yes. Thank you. Thank you so much.